Greetings, and welcome to Chapter 1 of my lecture series on virtual computing. I'm Ted Simpson, Cengage author, and this lecture series is based upon my recently released book, Hands-on Virtual Computing. In this chapter, I want to introduce you to the concepts, the technologies, and the products that are behind virtual and cloud computing, and that you'll be working with throughout this text or MindTap course. I've divided this chapter into 4 different parts or sections. Part 1 will take a look at virtualization concepts in pages 2 through 11. Then in Part 2, I'll discuss virtualization products and categories, including virtual desktop infrastructure. Part 3 will do an overview of cloud services and how they are part of virtualization or can be. And then Part 4, some of the features that you'll find in various virtualization products that we'll be working with. You may want to have your textbook or MindTap reader open during this lecture so that you can follow along at the different figures and pages that I'll be talking about. So let's get started with Part 1, an overview of virtualization technology. In this section, we'll be taking a look at how virtualization works, some of the advantages of it, describing the function of a hypervisor, the difference between type 1 and 2 hypervisors, and then some of the hardware requirements you need to run virtualization on your computer. On page 2, so we start out by taking a look at traditional computing environments, where a single computer supports only one operating system running at a time. And the operating system provides an environment for applications, manages hardware resources, and provides a user interface. If you install lots of applications, particularly on servers, it can provide some complex interactions between these multiple applications that can slow down the server, possibly cause it to crash. For that reason, it may be preferable to have multiple servers than to try to put too many things on one server. This can lead to inefficient power and hardware usage, because you may end up with a lot more memory and CPU power on a specific machine than you're actually using. Another issue with traditional computing is that the operating system's drivers are configured for the physical computer. This makes it difficult to move your environment to another physical box without reinstalling the operating system. Figure 1-1 on page 3 shows an example of a physical computer running a virtual computing environment. To make this happen, we need a special software layer called the hypervisor. And the hypervisor then allows us to create software computers called virtual machines. These virtual machines can have their own operating system and applications. So then this virtual machine becomes its own environment that's software defined. And the virtual machine frees the operating system that's running in it from hardware dependency, allowing this virtual machine to be moved between physical computers because the hardware and operating system are no longer directly linked. All requests for hardware services go through the hypervisor. Using a standard set of drivers, the hypervisor then accesses the hardware and returns the results to the virtual machine's guest operating system. To do this, hypervisor must be compatible with the physical computer hardware and software. And because the hypervisor acts as this buffer between the virtual machine and its physical hardware, virtual machines can move between physical computer environments, assuming they have compatible hypervisors, and also run in cloud environments. Virtual machines in this way provide for disaster recovery. If your hardware crashes or even a whole site goes down, these virtual machines can be launched on other physical boxes and other locations, continuing to provide services. Virtual machines also allow for load balancing. You can regulate how much resources are assigned to a virtual machine or move it between hosts in order to provide good performance. Virtual machines also allow for more convenient testing of software or system configurations. And virtual machines provide the ability to run multiple operating system environments simultaneously on a single computer or desktop. For example, say you want to experiment with Linux. Rather than having a separate computer or having to reboot your existing computer into Linux, you can create a virtual machine. Then you can install Linux into that virtual machine along with any applications or configurations you want to test. Hypervisors can be categorized as two different types. Type 1 hypervisors, also called bare metal hypervisors, run directly on the hardware of the computer with no need for any other software. As a result, Type 1 hypervisors are more, if you want to say, picky about their hardware environments, and you have to make sure your hardware matches the hypervisor's recommendations for it to work properly. On the other hand, Type 2 hypervisors run on top of a host computer's operating system. And they're often used to run other OS environments on your desktop. They're easy to install and use. They're not as hardware specific as Type 1 hypervisors. And they allow you to use your normal desktop applications while still running virtual machines. When we talk about virtualization, there's a couple terms that come up frequently. We've already mentioned virtual machines, and a virtual machine is, as I mentioned, a software-defined computer. The host computer is a computer that's running the hypervisor, and a guest OS is the operating system that's running inside of the virtual machine. Virtualization products are relatively recent, but the concept goes way back to IBM mainframes in the 1970s. In 1998, VMware, using these concepts, developed virtualization for the Intel x86 platform. They started out with VMware Workstation, which was a Type 2 hypervisor. It's currently in its 15th version, I believe. It's a licensed product, so you have to pay for a license in order to install it, although you can install a trial version, as we will in Chapter 3. And then they also have VMware Workstation Player, which is a free download, and of course it has less features, but is designed for the home market. VMware also has a Type 1 hypervisors, which they call vSphere, the ESXi hypervisor, and then the vCenter server, which allows you to coordinate multiple clusters of hypervisors running on different hardware platforms and then move virtual machines between various hardware boxes and so forth. It provides for load balancing and access to cloud environments and so forth. We'll be taking a look at vCenter Server and vSphere in Chapters 7 and 8. And they're currently VMware is a leading software provider for data centers. In the late 1990s, Connexa produced a Type 2 product and ported it to Windows. Microsoft later bought Connectrix and developed what they called Virtual PC 2004. I used this quite a bit in the early 2000s to run virtual machines in the classroom. In 2007, Windows 7 came out, and they used within it this basic concept to create Virtual PC 2007 that was integrated into Windows 7. Then when Windows 8 came out, along with Windows Server 2008, Microsoft introduced their Hyper-V product, which is a Type 1 hypervisor. Today, Hyper-V comes with Windows 2016 as well as Windows 10. We'll be taking a look at Hyper-V in Chapters 5 and 6. In addition to the major commercial vendors such as VMware and Microsoft. A number of companies also provide virtualization software based on open source. One of those is Oracle. Oracle VirtualBox is a Type 2 free download virtualization hypervisor, and we'll be covering using Oracle VirtualBox in Chapter 2. The Xen and KVM hypervisors are both Type 1 bare metal hypervisors designed for data centers, and again based on open source. The Xen hypervisor was originally developed by the University of Cambridge back in the late 1990s and is in use today by both Oracle for their data center virtualization and Citrix. KVM, short for kernel-based virtual machine, another open source Linux-based hypervisor, is used by both Red Hat and IBM in their Linux server systems. Okay, it's time for a quick break. Since YouTube videos are limited in time, we'll continue with part 1 after you take a little time to have a little coffee or just a quick stretch.